Yes, Sat Sri Akal students. Today we are going to study Law of Conservation of Energy, class 9, and chapter name is Work and Energy. Students, let's imagine that this is a height and there is a ball at the top of the height. It's a kind of sphere of mass m, right? And this is the ground level. In the ground level, we imagine that the height is 0. Just suppose that ground level is at 0 height, and the height total height between the ground level and this level on which the mass m is placed is h. Okay, now what is law of conservation of energy? This law states that the total energy of a system or of a body, total energy, especially of a system, is always constant. Let's try to understand how. Students, can you tell me that this mass is not moving at this height h? What is the total energy of the mass at height h? At height h, the total energy of the body is, please tell me whether it is potential energy or kinetic energy when the ball is not moving. Anyone? When the ball is not moving, it's simply here at a height h. The energy possessed by the ball is totally potential energy, because as per the definition of potential energy is the energy which is there in the body only because of its position, especially height. So what is the potential, what is the total energy of the body here? That is equal to mgh. Am I right, students? Mass into
Yes.
acceleration due to gravity into h. Okay, now let us say that these are two levels. huh? These are two levels I am just drawing. So first you tell me, students, as the ball will be dropped down, when you drop the ball from here, so before dropping, what is the velocity of the ball? Velocity is 0. So here, when the ball will pass through this point after dropping, or will pass through this point, or will touch here, whether the velocity will be constant or changing, especially if this height is more, let's say it is 100 meter, or more than that. It's a great height, 100 meter. Now when the ball is dropped, will the velocity here, or when it touches the ground will be same or different?
Different.
Different, because here the velocity is 0. So as the ball is accelerating with acceleration 9.81 meter per second square, so obviously it will, its velocity will increase. It will slowly increase. Maybe at this height it is v1, at this height it is v2, and then it is v3. Okay, actually in reality, students, when the rain is there, these are the clouds, and when the small drop of the water, when it starts coming down, when it is there in the clouds, its velocity is 0. I'm talking about a small drop. Then it accelerates, then the velocity further increases, and after some time the velocity becomes constant. It's known as terminal velocity. Okay, and this is the actual situation. It doesn't always keeps on increasing till it touches the ground. At some point the velocity becomes terminal velocity. It becomes equal to vt when the weight of the droplet mg becomes equal to, there are upward forces also, You may not be knowing. One is buoyancy force, you know, and one is viscous force acting upwards. So when these two forces becomes equal to mg, then the velocity of the droplet becomes constant. But here it's not so great height, 100 meters. We can assume that the velocity is increasing, v3. So students, what is the total energy of the body at one level? This is the this level we have no kinetic energy. Total energy is only potential energy, mgh. So at point 1, what will be the total energy of the sphere when the sphere will come here? So see students, I'm telling you, whenever you want to calculate total energy is always sum of in mechanical energies, potential energy and kinetic energy. Now the body is moving. Obviously it will have total energy at 1, at position 1 would be equal to, it would be some potential energy. Why some potential energy? Because this is the height from the ground. Am I right? What is the height? Let's say the height is h1. Okay. Here what is the height, students? When it is at v2, the height is h2. So at point 1, what will be total energy, students? Potential energy plus kinetic energy. So students, please tell me how you will find the potential energy at point 1. The potential energy is simply m into g, mass and g is constant, simply multiplied by h. So what will be potential energy, students, at 1? The height is h1. It will be m into g into, what is the height from the
H1.
ground? h1.
H1.
Correct. Plus, what is the kinetic energy? We have assumed the velocity here is v1. So it will be half into m into v1 square. Kinetic energy is always equal to half into mass into velocity square. Whatever is the velocity, uh, according to corresponding to this value of velocity, kinetic energy is this. When velocity changes, velocity becomes more, kinetic energy also becomes more. Fine. So this is total energy. Okay. Now, students, what is the total energy of the ball? The ball has further come down. The ball has come here now at height h2. So what is the total energy of the ball at 2? This is 2 level. This level I am representing as 2 level. This level is 1 level. Okay. So yes, can I ask one Rosedeep Kaur? At 2 level, what will be the total energy of the ball? The ball is at a height h2. It will have potential energy also, right?
So
And it is, yes, it is also moving. It is also, it's in motion, and the velocity is v2. It will have kinetic energy also. So please tell me what will be total energy at level 2?
so m into g into h2.
Beautiful. mgh2 will be potential energy, and kinetic energy will be half
Half
m
into m into
into
v2 square.
v2 square. Beautiful. This is the total energy of the sphere or the ball at level 2. Okay, students, now anyone can tell me what is the total energy of the ball at the ground level? Ground level. This is ground level. Here I assume h is 0. So again, you can say that the total energy is potential energy plus kinetic energy. Okay. So,
Energy.
so which
So
energy
here
will?
the energy will only be kinetic energy.
Kinetic energy. Why? Because potential energy, there is no potential, there is no height. So potential energy is 0. And what is the kinetic energy? Let us say the velocity is the highest velocity v3. So it is half into m into v3 square. Am I right? The law of conservation of energy says, very simply, it tells you, law of conservation of energy tells you that the total energy at the top level, what was the total energy at the top level? Total energy at the top level was mgh, right? This energy is equal to total energy at 1. At 1, what is total energy? mgh1 plus half mv1 square. What is the total energy at m2 at point 2 mgh2 plus half mv2 square. What is the total energy at the ground level? At the ground level, total energy is half mv3 square. This is exactly, students, what we mean by law of conservation of energy. Here there are some interesting things. You see, we can observe that the energy is getting transferred, energy is getting transformed, sorry, from one form to other form. Just see, at students, at this point, at this point, the total energy of the ball is potential energy. Am I right? And that is equal to how much?
Yes, sir.
Mgh. At the ground level, the total energy of the ball is kinetic energy. So you can say whatever is the potential energy of the ball at the top level, mgh, mgh totally converts to half mv3 square. You can do the calculation also practically. You will find mgh and half mv3 square both will be equal. Anyway, you know the unit of potential energy as well as kinetic energy is same. What is that? Joule. That is a unit of work done. So they'll be same. Also, students, at intermediate positions, that is at level 1 and level 2. At level 1 also, the body is having height also and velocity also. So its energy will be sum of potential energy and kinetic energy that we have calculated, mgh1 plus half mv1 square. At the 2 position also, the total energy of the body is a sum of potential energy and kinetic energy. Very simple. When height becomes 0, there is no potential energy. When velocity becomes 0, there is no, come on students, come on,
Kinetic energy.
there is no kinetic energy. So you see, the energy is getting transformed into, first it was total potential energy at the top, total potential energy, no kinetic energy. When it dropped down this much, slowly some part of potential energy decreased because height decreased and kinetic energy increased. When it was dropped by the height h2, potential energy further decreased. mgh2 will be less than mgh1 and mgh1 will be less than mgh. But the kinetic energy increased because V2 is increasing, this is increased. Finally, students, potential energy keeps on decreasing and becomes 0. And kinetic energy at the upper level, kinetic energy is 0. From 0, it is increasing to half mv1 square, then increasing to half mv2 square, and finally what is the value for kinetic energy at ground level? Half mv3 square. So we can say that, students, in the next slide, that as this is the body, as this body is moving down, let us say this is the ground level. Here total energy of the body is potential energy, and total energy of the body is kinetic energy because h is 0. Here total energy is potential energy because v is 0. Body is stationary, no velocity, there is no kinetic energy. V is 0, kinetic energy is 0. As the body is moving down, its potential energy is, yes, tell me
Decreasing.
student, decreasing. And slowly the decrease in the potential energy, decrease in potential energy is equal to gain in
Kinetic energy.
kinetic energy.
Kinetic.
This is so many forms we can state law of conservation of energy. That means, you see, the total energy of the body here was potential energy. Potential energy is changing, it's decreasing, but that decrease is converting into kinetic energy. That means total energy is remaining constant. The total energy during this fall, the total energy of the body, you can calculate at any point, point 1, point 2, 3, point 4, 5, point 6, point 7, 8, 9, point 10, 11, 12, point 13. At any point, you can calculate the total energy will be a constant, and that constant will be equal to the total potential energy at this point. At this point, total potential energy will be mgh. If I take this complete height from the ground level as h, and the total energy, that constant would be equal to mgh will also be equal to half mvgl square. What is vgl? The velocity of the sphere when it hits the ground level. So this is conservation of energy. You know, something more related to this, students. You see, when we are speaking, I'm speaking, you are listening. It's very interesting. Our vocal cords are vibrating. We have our vocal cords, they start vibrating. So it's a kind of vibrational energy, right? Vibrational energy. And that is produced from the muscle energy. Muscle energy is getting converted to vibrational energy. Vibrational energy is getting converted to what you are able to hear. That is sound energy. Very strange. Very strange. We can see, hope there is no more bomb explosion in this world, right? When there is a bomb explosion, in the bomb explosion, the nuclear energy is getting converted to sound energy and also getting converted into lot of heat energy. You hear a big explosion whenever there is a bomb explosion. Explosion is a lot of heat energy, sound energy. So there are lots of kinds of energies. They're not coming to my mind. So simply these energies, that wave energy is also sound energy and heat energy. No? So sound and nuclear energy is getting converted into that, right? And then, you know, when you are driving a bicycle, or when you are driving a bicycle, your muscle energy, the muscle energy of your legs as well as your upper limbs also, that is getting converted into kinetic energy of your bicycle. So, you know, it's always the conversion of one form of energy into other form of energy, which sometimes we observe, sometimes we are not able to observe. So nature is, you know, indirectly behaving in a very interesting manner. The total energy is actually remaining constant. Energy is simply getting transformed from one form to other form. We can also say the total energy of the universe is also whatever energy was created, it is remaining constant. You can also talk about energy of a tree. You see, the tree is so big. You might think that the tree starts from a small seed, and very strange style of nature, students. Bigger is the tree, smaller is its seed. The banyan tree and people tree, their seeds are so small, you won't be able to have in your fist, in your hand also, and they will आपकी उंगलियों के बीच में से छोटे से निशान जो थोड़ी स्पेस है उसमें से नीचे चले जाएंगे वो. And see, that small seed transforms into such a big tree. So it's a lesson for you also. If you're very small, आपको नहीं समझ आ रही है आज, you are not understanding physics or maths, you are बहुत छोटे हो आप उतने अगर आप अपने अंदर एनर्जी लेकर आओ कंसेप्ट्स की, आप अच्छी तरह से टीचर को सुनो, मेहनत करो, डेडिकेशन के साथ पढ़ो, you can convert yourself into a banyan tree also. So it's all transformation of energy. अब छोटा सा सीड है, वो इतना बड़ा पेड़ कैसे बन गया? ठीक है, ultimately water, then sunlight, then fertilizer, then nutrients in the soil. So all, it collected energies from all, and ultimately that energies got converted into mass, such a big mass of banyan tree. So it's always conversion of energy from one form to other form. That is law of conservation of energy.